All right. So today we are going to be talking about proportional reasoning in tables and equations. And just a very quick recap of the lessons that we should be doing right now. There are 2 lessons this week: proportional relationships in tables and graphs, and then using proportions to solve problems.
That's what I'm on.
Awesome. After this, we only have 5 more lessons to go.
Yep.
So we are almost done. So today we're going to talk about this first lesson, and then tomorrow we'll be looking at using proportions to solve problems.
Oh.
So the first thing we want to look at is vocabulary. We have already talked about vocabulary being a rate of change, where it's a rate of change which describes how something changes in relation to another. And we talked about how we can find it by finding the change in y over the change in x, and that gives us our m, which is rate of change. We have our constant of proportionality, which is the ratio between 2 directly proportional quantities. So we only have a constant of proportionality when it's a proportional relationship. We use the letter K, and we can always put the values of y over x. And then lastly, a proportional relationship is a relationship in which 2 quantities are equivalent ratios, and their graph is always a straight line that has to go through the origin. Has to go through that origin right there, and it has to be a straight line. Are there any questions about some of the vocabulary that we just went over?
No.
Awesome. Great. So the first thing right off the bat, when you look at these 2 things, what do you notice between these 2 tables?
The one OZ is different from the 2 IB.
Okay. So we have ounces here and then pounds right here. So that's not the same quantity.
No.
So even though it looks like we did times 2 on both sides, is that going to be a proportional relationship?
No.
No, because you're comparing 2 different quantities right here. So then when we look here, we have weight and price still. We have half of a kilogram is 75 cents, and then 5 kilograms is $7.50. So we want to see if this is proportional. Our weight would be our independent variable, and our price would be our dependent. So if I can put all of my y's over their associated x's, and they will be equivalent, then this will be proportional. We're going to find our calculator. So we have 0.75 divided by 0.5. That is 1.5. And then we have 7.5 divided by 5. That still gives us 1.5. So were these ratios equivalent?
Yes.
Yes. So this would be proportional. And then our value for K, which is our constant of proportionality, would be 1.5. So we can write a rule that y would equal 1.5. You have questions on that, guys?
No.
Do you also see how this is proportional? Because it doesn't have a plus or a minus anything on the other end, so it would go through 0, 0.
Mm-hmm.
Okay. Now we want to see proportional relationships with tables. So this ratio where we put y over x, this is our K. What is 75 divided by 1?
75. 75.
75.
So that equals 75. What is 120 divided by 2?
60.
So are those ratios equivalent?
No.
No. So is this table on the left is gonna be proportional?
No.
No. No, because every time you take y over x, it would be equal in a proportional relationship. If y over x
Yes.
is
If you
not,
mix 18 blue drops with 12 red drops.
Sorry.
oh, you're fine. If y over x does not equal another y over x, then it will be not proportional. So we know that this is not proportional. Well, what is 45 divided by 1?
45.
What is 90 divided by 2?
90 divided by 2.
45.
What about 135 divided by 3?
Is it still 45? I'm just guessing.
Let's check. 135 divided by 3, it is.
Oh,
So that is proportional table 2.
It is, but we want to make sure we check all of them because sometimes you know how they like to trick us and it'll work to the very end.
Yeah.
So we have 180 divided by 4, which still gives us 45. And then lastly, 225 divided by 5. Which is still, 225 divided by 5, which is 45 still. But because all of those ratios were equivalent, this is proportional. And my k is going to be 45. So I can make an equation that y is equal to 45 times x. Does that show the relationship we see when we multiply by 45 each time?
mm-hmm.
Yes.
Good. So this would be proportional, which means it would go through what point?
The origin.
Very good. Now, using rate of change to solve. So now we're looking for a missing value. So weight and price, we're going to assume in this aspect are proportional. I'm given that I know 10 pounds is $18.24. And I want to know how much 2.5 pounds would cost. So the price shouldn't change per pound. So if I know what 10 pounds is, can I find what 5 pounds is?
Yes.
Yeah.
How?
I want to say splitting the price in half, but I don't.
Right. Well, shouldn't 5 pounds cost half of what 10 pounds costs?
Yes.
Okay. So then 5 pounds would cost $9.12. And if I know what 5 pounds costs, can I go back to 2.5 pounds?
Yes.
How can I do that?
Divide.
Divide
by.
2 by 9.12.
I can divide 5 by 2 to get to 2.5, which means I would divide 9.5 by 2 to find my missing price. So I have 12 hundredths divided by 2. So I take 4. We get 456, which means 2.5 pounds cost $4.56. What if I'm right here and I know that 5 pounds costs $9.12, and I want to find what it would cost for 15 pounds?
Then just multiply by 2. Oh, multiply. Okay.
Multiply by 3.
Yeah, 3.
I could multiply by 3. So then to find the price, I would multiply 12 hundredths by 3 to get 27.36. Do you see how we think multiplicatively in this table? So we're always multiplying or dividing it with proportional situations.
Yeah.
Okay. So then for this one, when it comes to graphs, I want to find which of these 3 is a proportional relationship. So is this first one a proportional relationship?
No.
Why not?
This one's not.
It's
It's
not for the origin.
Good. So it's not because it does not go through the origin. What about the next one?
No,
it's not really the origin.
They're the origin.
It does not go through the origin. And then what about the last one?
Yes, it does go through the
Origin.
origin. So it is.
Yes, because it's a straight line. It's a straight line. And it goes through the origin. There's two things that we need to happen. Good. All right, so this last part, we want to find our unit rate. So remember, unit rate always is when you're comparing something to one of another. So if I'm looking at this table right here, and I have D as dollars and P as pounds, this point right here tells me it costs me how much for 1 pound.
Mm-hmm.
How much does that table cost for 1 pound?
$2.
Good, $2 for that 1 pound. So then which column would it go in, the left or the right hand side?
It would go on the
On the left side.
Good, so I'm just gonna draw an arrow. It's gonna go over here. And then now we wanna look at these equations. And now notice the word that's at the very top. It says use substitution. Substitution is when you plug in something for something else. Kind of like if basketball, players sub in and out. Same with volleyball and football. So I'm going to start with this first equation. I have half of D, which stands for dollars, is equal to 2 pounds. But if I'm trying to find the unit rate, that means that I am looking for the dollars when it's how many pounds?
1 pound.
Exactly 1 pound. Very good. So if I want to use substitution for this equation here, I can plug in 1 for P. So I get half of D here is equal to 2. Well, if half of D is 2, what would 1 whole D be?
4.
Very good. So then that unit rate means it costs $4 for 1 pound. So would that go on the left or the right hand side?
The right side.
Very good. Good. That would go here. And then the next one, again, so now I have D is equal to 2P, but I still want to know what it costs for only 1 pound. So what number will I plug in for P on this second equation? So I'm looking for dollars when it costs for only 1 pound. So what number is going to go in for P?
2
Oh, P is supposed to be 1. And
P
so
will
they're matching, so they're supposed to multiply.
So D will equal 2 times 1, because I want to find the dollars for only 1 pound.
Mm-hmm.
That D is actually just equal to what?
2.
2. So then which unit rate will that one go with? The left or the right?
Oh, it'd go to the left.
left.
Good. I'll go over there. Do y'all have questions about that and how I plugged in 1 for pounds?
I understand that.
Okay. Shirley, does that make sense right there? Ma'am? Charity, are you good with that part so far?
Yes.
Awesome. Great. Well, that is our last part. So I'm going to come back.
That was fast.